My name's Steve. I've had a long and tumultuous history with Jenkins. Prior to joining CIVO, I worked for Open Universities Australia, and we did a fairly big migration of all of our on-prem stuff into AWS, and as part of that we made a really concerted effort to everything as code. So lots of classic old RHEL 4 boxes, manhandled and wrangled into AWS, all running Chef as code. What lived at the heart of our system was basically our CI and CD pipelines. And at the time, Jenkins was hitting a bit. But the thing that always troubled me was that these services were still very manually crafted and handcrafted, and they had like keys to the kingdom in them, and they were like the single point of failure. It's how we did deployments. It's how we recovered from certain classes of failures. It was how we did a lot of operational activities of whitelisting different people into environments. But a lot of it was very handcrafted Jenkins boxes, still running in Amazon, but people were unwilling to touch it. And if any of you have played with Jenkins, you realise it's a temperamental beast, especially when it comes to plugin upgrades and plugin conflicts and things that have just decided to go bump in the night. So we thought there had to be a better way. So this was 2, 3, 4, I don't like to know how many years ago it was now, but too many years ago. And so we sort of started down this pattern. And since my time at CIVO, we've run into nearly every one of the customers who's had exactly the same problem. They have a set of handcrafted Jenkins servers, either be on-prem or on the cloud, or potentially even under your desk, that do a lot of magic for the machine, but we don't treat it with the level of respect that we do for application code and other bits and pieces. So this is a deck I've done previously. It's a part of a much longer presentation about everything, so I'm going to try and squeeze it into the time I've got available today, which is only been another 15-20 minutes. So when we look at Jenkins, really there are 3 layers that we want to think about. So we've got the infrastructure that it runs on top of. How do we provision it? The pieces that run for it. Then we've got the actual Jenkins application itself. And then we've got the actual jobs. So a lot of the times, if we're in AWS, we've got ideas of this being, CloudFormation, Terraform, depending upon your tool of choice for code here. But maybe we're still just standing up boxes and then going into the GUI and hand configuring our way through. So you can do it, the whole stack. And one of the patterns that we've used a lot is to replace the handcrafted EC2 Jenkins install boxes with a set of Docker containers. And then on top of that, continuing the configuration of the jobs through Groovy, through the Jenkins DSL for build pipelines, and now moving into Jenkins files all the way up the stack. So hopefully I don't need to explain why everything as code is a good thing. We create that consistently repeatable process, which is highly undervalued in a lot of development teams, because they often, me being one of those devs, often only think about it once. I built it, therefore it's good. But after we've had things running for more than 3 hours, managing it, maintaining it, updating it is a problem. It also enables a really strong self-service workflow. So a lot of this stuff is more than trivial. It's not as simple just to start a box and run it. There's security and network and ingress and keys and. So encoding all of this as code into a workflow that allows people to pull for the service, it's really powerful. Gives us awesome visibility on change, and that's really the key part that I think is the big benefit you get out of an as-code approach, is because everything goes through the code, because everything commits to the repo, we can start to see what changed, and hopefully people's commit messages are good. We'll start to understand why they made that change as well, and start to be able to trace back where those conflicts come from, and of course gives us really good roll forward and rollback. So there's lots of other reasons you might talk about everything as code, but they're really the 4 that I like to talk about. So let's start at the bottom. Let's look at how we do this. So hopefully, to you guys, if you're all up to your eyeballs in the AWSs, it won't be news to you, but that we're building in the cloud, we should be building infrastructure as well. If you're clicking and pointing through the console in AWS, you're doing it wrong. It's pretty simple. I have a very strong opinion on that, because as soon as you start to mutate those things, all of the preceding values that you've had of traceability, of repeatability, of self-service go out the window. and we start to head back down that specialization route that makes single points of failure in the organization. So we have to do this. It makes it really easy, especially for a Jenkins cluster. So what we really want is teams to be able to run their own. I'm going to move away from the monoliths. So we've got big application monoliths. Why do we have one big Jenkins monolith? It's one single point of failure. It's one single point of security. I can't upgrade something without talking to everybody else to see if there's a breaking change. Whereas if we run this stuff as infrastructure as code, I can have mine, Trent can have his, Jace can have his, and we can all run subtly different versions and different pieces as we start to move forward. So what does a Jenkins as code infrastructure look like? Well, in this scenario, we're going to run this as a set of Docker containers, and we're going to isolate the masters from the agents. So you end up with a really straightforward, multiple availability zone deployment mode, where we have an auto-scaling cluster out the front of master hosts, which will host the master Docker containers. So they'll run the Jenkins master that you would previously run. And then we run an auto-scaling group of agents underneath, which is where the tasks or the slave containers get run. Now, luckily, Jenkins is really awesome in that it has a plugin that supports this. So there's actually a plugin that allows a master to detect a new job requires a certain agent, and it does all the orchestration of launching the task on the EC2 cluster in the agent space. And then it connects back to the master and phones home like any slave agent does, runs the job, and then the task gets thrown away, which is really awesome when it comes to mutating the state of your agents. So I'm assuming if you're running something like this, you've got lots of agents running, and they've all got different versions of PHP or Java or different sets of tools, and you've got a whole lot of complex labels to work out which nodes to run on what. And then you've got contention when these two jobs are trying to run at the same time, and XVFB needs to hook to a port, but that port's in use, and so you've got to make sure the parameter of the job's right so that it automatically increments. But then you've got to pass the parameter through to your script so that it gets called. None of that exists with the container isolation. All the containers reset to a fresh base every time, and as you'll see in a second, because they are code, you can revision them and add new tools to them and upgrade them in the same workflow. So this is simplified because realistically, it actually looks like this. So this is everything you need to handle a full auto-scaled ECS cluster peered into the Jenkins master. So all of these extra moving parts are to allow this cluster to scale with demand. So right now, you might have, we've seen clients that have 600 to 800 builds scheduled on their master server, which are sitting behind a cluster of 14 or 15 boxes, which are running hundreds of dollars an hour maybe of compute, but they only use that for 8 hours a day. Now there is auto-scaling, but no one ever really gets around to actually using auto-scaling properly. But by using some of these CloudFormation stacks, what you'll get is alarms that trigger when the reservation on the ECS cluster is above a certain point. So whether it's memory reservation or CPU reservation, whatever matters to you. And once it's above that point, the auto starts to scale up the backing hosts to make sure that there's more compute available in the cluster. And then there are alarms on scale down to watch for those falling below certain reservation levels. And then there's a set of polling jobs, though, that need to make sure that the tasks are actually drained from those hosts before they're removed. So there's a set of auto-scaling lifecycle hooks as well. All of this shunted out to CloudWatch logs because, hey, remember all of our servers are containers and they're going to get thrown away. So how do we make sure we manage state? So that brings us up to the clusters. So let's take a look at these two layers. So we're running Docker in a container for the master, and we're running containers for the Jenkins agents. So it probably makes sense for the agents, right? Like the agents, they sort of come and go with the builds as they're needed. But we can have, say, 3 or 4 different flavors of agents, which have got different operating systems maybe, with different tool sets on them. And we can use the label indirection to launch the appropriate agent on the appropriate host. But what about the master? The master has state, right? It has log files, it has build IDs. This is where we start to think about how it impacts our development workflow. So I guess the really important part is to reiterate what I've been over is that Jenkins is an application and we should treat it like an application. We shouldn't treat it like a thing that we just build and throw away in the back room and hope that it works forever, because in 6 months' time when it breaks, no one will know actually how to recover it. So treat it like an application, use a Docker deployment workflow for it, and start thinking about how we move towards an immutable infrastructure approach. The good bit is that the Jenkins guys have done most of the hard work for you. There's a Jenkins master agent and Jenkins slave agents that are available in Docker Hub right now. So all we normally do is we take them and extend them a bit. So from the base master, install a couple of extra tools, do a Jenkins update, and then install a set of custom plugins. So there's a whole rich CLI that exists underneath Jenkins for you to automate and orchestrate the server and the services. It can be done from bash type commands here, or it can be done from a set of Groovy scripts to automate inside the agent itself. What this lets you do is effectively hot start a container. Boot the container up and have all the plugins that you actually need available, all the right versions. You can see things here. There's an actual issue with the build pipeline plugin and the delivery view where they progressed at some point in time. We can still put version numbers in here. If you actually look through the version history of, maybe not this repo, but the repo that the screenshot was taken from, you can actually see over time as those upgrades broke, the troubleshooting that was done, the comments that show that it was rolled back. The next level of this is to work out how we start putting tests around it. The agent's really similar. So this is a Terraform Packer agent that we're building. So you can see it's from the Jenkins CI slave, install a set of standard packages, install a certain version of Packer, a certain version of Terraform, and even in this case, TerraGrunt. We can reuse those and build up a suite of agents then, which all have different workflows. The really cool bit is when you start to get Jenkins in Jenkins. So having Jenkins jobs, watching these repositories, building agents, publishing those agents up, publishing back to the repository, so that the next time the job runs, it actually uses the updated toolchain. The actual really awesome part is when you do Docker on Docker with this, because the agent is running in Docker, the Docker pull for this container is effectively a no-op, because the container is already on that host. So it actually makes your Docker builds super fast when you're doing Jenkins builds, because everything's basically cached locally already. There's your free one. So Jenkins in Docker is configure your plugins and stick them all in. But one thing that a lot of people talk about is what about state? I prefer to try and build pipelines without caring about the state. If the logs are important, ship them, which is what we would do with applications, right? We don't leave the application logs on the application server. So if the logs are important, put them in your log system. And if your build IDs are important, then don't make them important. Use something else, use an external versioning tool. So a lot of cases where we're using Jenkins build IDs, just use ISO timestamps. If you can't think of anything else, just put that in. It'll do. It'll be incrementing, monotonic or not monotonic, it'll be incrementing, so it'll be a timestamp, but it'll be unique. It's easy to calculate, it's easy to see the difference between two of them. And we start to be able to get away from that. And the reason is as we move into the next layer, we want the jobs and the builds and everything to be immutable. We want to be able to treat our Jenkins build processes in a similar workflow to that which we do our application builds. So we're starting to think now about tearing the entire application down and building it back up. One of the key pieces that always is a pain when we do that is state. We've got a 4 terabyte database that I've got to restore every morning because you keep tearing the thing down on me and rebuilding it. So how do we start isolating that state? How do we start separating it from the compute? Let's look at throwing the compute away regularly and bringing the state back. So the hack on the previous slide is actually to mount the Jenkins home into the source container. So at least you can throw the master container away and bring it back, and it will remount the Jenkins home with the jobs folder and all those pieces. Obviously, if the backing host scales underneath it, you lose it. But if you really cared, you could store it and rehydrate it. You could mount it to EFS. I want to play with performance testing, how that works on the EFS soon, just to see the fun of it. There are ways to do it, but try not, is the simple answer. The less you care about the state, the less the state is in your Git repositories or in S3 or in some global repo, the more repeatable this workflow will be. So in Jenkins now, there's basically 2 layers of configuration. So there's cluster configuration, and then there's job configuration. So the cluster configuration can be done either at build time through those bash scripts installing the plugins and baking them into the containers, or provisioned at boot time of the Jenkins master. So Jenkins will actually run, this is the first piece. So the first piece is for SSH key access, we stick a key in S3, which is encrypted with KMS, and the KMS key is only allowed to be decrypted by the Jenkins agent master, the Jenkins master agent, which is then pulled down and stuck on the box. So we don't have any secrets baked into the images. My image can be different to Trent's image because we give it a different bucket name. Mine pulls from my team's bucket, yours pulls from your team's bucket. The policy set up around them is different. Ownership is different all the way up the CloudFormation stack. And the second part is the Groovy script. So I don't know if anyone knows, but there's this Groovy init workflow that exists. So you can drop a Groovy file in Jenkins home init Groovy, and it'll run at boot. So there are a few things that are already in there by default. I think some of the JNLP port stuff and some security things are set up to be configured, but you can extend this. So I've got an example repo, but it does things like builds the cluster, so pulling ARNs, passing ARNs through as environment variables to the container, passing subnets and security groups and IDs and things out of CloudFormation into the container, and using those environment variables to actually build Jenkins constructs, enable security, connect up with LDAP, all of that stuff that you'd have to do to provision the actual cluster itself. Jenkins is just Java. Everything is just Groovy in the end, and so is easily put through here. And the last step that I normally do is I inject this Jenkins Bootstrap job. So the Jenkins Bootstrap job is the first job that gets built on the cluster, and all its job is to do is to run a build process to generate all the other jobs. And so that is where I prefer to use the Jenkins DSL for this. So the new kids on the block are playing with Jenkins files, and we can have a beer one day and we can talk about the benefits and the curses of Jenkins files over Jenkins DSL. Maybe I'm just old. But it looks a lot like there are parts of it that look very similar. They've obviously taken a genesis from each other. But the Jenkins DSL, so there's a repo here, which I've been working on, which has a set of example Groovy scripts, which set up a simple pipeline, multiple jobs wired together into a delivery pipeline view, that do a build and a test and a compile and a publish. There's lots of documentation available on the Jenkins DSL, so even if you're not using all of this as code, I definitely recommend look at this piece, or at least, I don't know what angle Trent's pressing, but at least Jenkins files. Because getting the repeatability in the code at the job stage is the first step to making the rest of this really repeatable. What you get is something like this, and because it's Groovy, you've got all the constructs of Groovy. I've got a better example, but say you've got 54 Java modules that all get built with a really similar workflow, and they all do a checkout of the repository, and they generate a set of pre-processed stuff, and then they run a Maven compile, and then they run a Maven publish or something. You can have that same Jenkins file copied in 54 repositories, or you can have 54 copies of that same job, or you can have the job with steps wrapped up like this, and a for loop outside them that says this repo, this repo, this repo, this repo, this repo. And then the pattern most probably internally for your Git repositories will be really common, so they'll all be in the same project. So parameter, whatever it's called, stick the parameter into a string. That word called this stuff.
Templating.
Thank you, templating. That'll do. Templating. So, like Captain Planet, let's bring it all together. So, as the human, I build and publish the initial Docker containers. So this is still a workflow in progress. So check out those repos, build them, push them up to your container. and push a set of keys up into S3, and then launch the CloudFormation stack or Terraform or whatever it is you're using. That will build you the ECS service, retrieve the Docker images from ECR, pull them down, launch the ECS tasks and services, which then in turn downloads the keys, runs the Groovy config, and launches the master process. So from a couple of small steps, and honestly per organisation, usually these first two are done once, this starts to become a very big self-service pattern where every team launches the stack with a different set of parameters. It's a different repo to watch or a different initial build job, and the rest of it becomes fully automated. So that was my whirlwind tour. I think I made it in and out in about 25 minutes or so. That's not the right button, there's another button, press this one. So there's lots of other stuff that I like to talk about. How to actually migrate and adopt this approach, the DSL versus Jenkins files, but we'll have to save that for another brown bag lunch.